Hey folks, and welcome to our second webinar in the AI in Design and Construction series for the BIMForum. I'm I'm really interested in this topic. I think it's one of the most fascinating and fastest moving parts of the AEC tech landscape today. So thrilled to be joined by Radu and Adam. And as always, please ask questions, post them in the chat, and we'll be posting this to YouTube when we're done. So if you can't stay for the whole thing, don't feel bad. We've got you. You can watch it later. So that being said, Radu, over to you.
Thank you, John. We're basically going to have a conversation over generative design by and large, and in that sense, we'll start with a bird's eye view, essentially, on some parts of what this conversation could be about. Um, and I'll introduce a couple of concepts which I think are useful as we sort of narrow into the topic. And this will be for probably 5-10 minutes, and after which we'll switch to Adam, who's going to make a longer presentation on some case studies he's been undertaking. Before we start with that, some logistics on AIA credits, which have been approved. In order to get these credits, you'll need to send over to us through the chat or comments your AIA number, so we can make sure that you're credited the credits for this. I will let Adam introduce himself. He has the big topic here, and I'll introduce myself after that.
Yeah. Thank you, John. Thank you, Radu. I'm Adam Davis, currently moved out of the VDC landscape, more adjacent in the fabrication and modularization world, but been inside of construction design for about 20 years. You can see I've been fortunate enough to participate in some of the BIMForum Working Group Advisory Board initiatives and contribute to the most recent LOD. Excited to be here and share some of what we're learning as we play around with generative AI.
Thank you, Adam. My name is Radu Dicher. I'm also involved with BIMForum work, the co-chair of its civil landscape domain group. I'm a firm-wide BIM manager for SWA Group, which is a landscape architecture, urbanism, and planning practice in the US with global footprint and global projects. I'm a sustainability accredited professional. I'm also the co-chair of the Digital Technology Professional Practice Network for the American Society of Landscape Architects, a mouthful in that, and also the co-chair of its BIM working group. And there's a lot going on the realm of landscape architecture and BIM, and generative design and AI and digital twin and other technological advancements. I think are a big part of it. So kind of diving into the topic, a very, very general definition for generative design would be a process by which data inputs computationally generate design. So we're going to have a bunch of definitions around this through our conversation, but this would be a very sort of general approach to that. And from that perspective, I think it would be useful as the there's a sort of an eclectic character to the topic, I think, where we're talking about AI, generative design, electrical design, and we'll touch a bit on architecture and sort of a bunch of other topics. I will basically talk first about generative process per se. Then I'll introduce a bit something closer to the actual topic, parametric design, and then generative design will sort of make that more specific, essentially. So what do I mean by generative process? And this can be a quasi-analog or fully manual process, but it's essentially it means employing an algorithm or formula to actuate on site or building collected or design intent data, actuate this formula, this algorithm, right, in order to generate something that was not visible otherwise from the subject of study. And we'll see that just as in the case of parametric or generative design, it is critical to design an algorithm or formula which turns out useful information from the subject of study. And this means, and this is something that will appear in parametric design as well as in generative design, iterations are essential, and sometimes these could be iterations of iterations, because the formulas and the algorithms themselves may need to change to provide this useful data. And to make this a little more specific, I'll introduce a couple of studies I've done as a graduate student at the MLA program at IIT Chicago, Master's Landscape Architecture. And for instance, this one uses basically a visual algorithm, a computed visual representation of a poem by creating a visual symbology, keying sound, vowels in particular, to on an XY graph, right? So this essentially articulates sound on a visual cue. The purpose is to transpose sound into image and create a shaped space, a mapped space representation of how this sounds, how the poem sounds. And ideally, this would reveal new information that was not visible, because I think what this does is transpose a sensorial interface with another. So do we get anything new by doing this? It's an open question, but it's a methodology I'm trying to introduce. A second project involves algorithmic site activation. And in this, basically, I'm mapping visibility and experiential access to space within a site along a path. And there's an XY aspect to this, and also like along this path visibility aspect that I'm trying to involve. And it's basically eyesight lines. It's not very complex, but the idea was to sort of see what is conspicuous from the site by its current conditions. Essentially, kind of like a field representation that charts gradients of visually accessible versus inaccessible space. Now, that's a generative approach to data, site data or poem, poem data. But in terms of taking this one step forward, parametric design per se relies on this parametric model idea, which is basically model of a design using parts with some properties fixed, which are the constraints, and some others that can vary, right? And also, this basically then relies on an iterative approach, right? But there's no quality control to the output, which is, we'll see, it relies, basically goes into generative design, typically. Some typical examples for parametric design that are oftentimes brought about are Antoni Gaudí, basically, who used a computational model, completely mechanical, right, to generate design, in which the input parameters were, these are basically weights hanging from strings that can then be pulled and moved around so that the design would change depending on the physics of it, right? And so the input parameters in a parametric design framework would be the string length, attached weights, attachment points location, the equations that drive the parametrics, the flexing of the parametrics are, gravity and Newton's laws of physics. And the output are basically the anchor locations of the points on the string. So you get different configurations by changing these values within the constraints built into the model. And basically also Gaudí's other sample is the Sagrada Familia, where the column design also relies on parametric geometry simulating plant growth. There's organic forms essentially employed in the church's design, where 3D shapes are generated by 2D sweeps. And basically this the parametric nature of this design basically allowed generating new forms even past Gaudí's death. So it's a very interesting metaphor, I think, of like future of construction, in the sense that parametric design allows actually new design to emerge from existing parametrics, right? So once you have the constraints and the formulas or algorithm or sort of the laws I mentioned in the prior couple of examples, this can propagate and generate design essentially. Another example, Buckminster Fuller, and his systems paradigm approach, that where basically a module component generates iteratively based upon its specific characteristics, such as the tensegrity, the tension and integrity, which is his term, generate a design, right? So the component basically then assembled in the laws that are driven by its characteristics, again, tension and integrity, are ultimately generating the design. Now, taking this one step forward, what are the differences between parametric design and generative design? Typically, generative design adds iterative validation and optimization to sort and evaluate the iteration. So parametric design typically doesn't involve, or historically may not involve, validation and improvement by iterations necessarily, right? While generative design does. And to that end, we're kind of like diving into the topic at hand. What is the best sort of tool that can provide this validation, this improvement of iterative design, which may be made possible by parametric design? And I think AI is the perfect tool. So we've experienced the emergence of AI in the past few years, and there's a few concepts which kind of govern this the doings of AI within this framework, machine learning, which is fairly widely known. Generative adversarial network involves two neural networks competing with each other in a zero-sum game. That's what that means. But this is basically able then to sort of iteratively improve the design. And reinforcement learning is something similar. It's another sort of paradigm of machine learning where an agent takes actions in ways that maximize a cumulative reward, right? So these are just like some components that articulate AI within this framework. But I
Radu,
will then, yes.
Real quick though,
John.
can we back up, because I think I was tracking you through Anton Gaudi and Buckyballs, which I love. And then we talked about, and that was essentially the history of parametric design, right? Like,
Yeah,
all the different ways that parametric design existed before a program that we love to hate and hate to love called Revit, right?
yes.
When you say generative design, let's just make sure we nail that definition, because I feel like those are the fundamentals of AI and machine learning and all of that wonderful stuff. So when we say generative design, it's an iterative validation and optimization. So we're essentially taking all that parametric information, applying some constraints to it, and running it through various iterations to find potential solutions. Is that what we're saying generative design is?
I think the definition I'm suggesting we adopt is that where, if parametric design was a little agnostic of its the fitness of its results, generative design is not. Generative design becomes an improvement process, iteratively improving its result towards against constraints, goals, against certain metrics that evaluate and validate its output. That's I think that's how I propose we look at generative design versus prior similar work.
Got it.
And I will hand over to Adam.
Awesome. Well, Radu, you've done a great job of more eloquently speaking about the history, process, and current kind of expectations around generative design and parametric design than I ever could.
It made me feel just a little bit dumber.
Yeah, that's what's been great in preparing for this, is that I'm I'm very specific inside of the MEP electrical space, and you're so far on another spectrum with the landscape design and the duality there, but the similarities have been fun to explore during the preparation of this. So
unfortunately, I also have a physics and history background, which is plenty transparent on the historical approach. To, not that I want to say I don't think this historical overview that title is a little big for what we've done, but I think the introduction of some concepts and thinking frameworks would be useful for guiding the conversation.
Yeah, and it helps define the rest of our discussion here. And I could tell that you had that background. No, thank you. Well, again, we're talking about large subject. We're going to kind of go micro focused into an electrical subcontractor or electrical contractor's perspective. There's other applicable, users of this type of generative design. And then everything we're talking about in the case study is going to be in relation to a tool called Augmenta that's out there. And we'll have a slide up at the end to kind of look at how you can connect them more. There's other available tools that are emerging for this type of thing, but essentially that's how we're going to guide today's discussion. Again, Radu did a great job of talking about what is generative design. But again, another general statement about it, a set of technologies that approaches that allows us to automate complex design tasks. Something that's helped this come about a little bit more recently is like we have a lot more access to a lot more computing power than we did in the past. So the lower cost of entry and the easier a point of entry to some of that computing power is helping this kind of take different tracks like electrical contracting. Seeing if I can click the magic button here. There we go. So as it pertains to electrical contracting specifically, and specifically inside of electrical conduit routing systems, we're going to be speaking specifically about how it deals with conduit size, hangers. It's going to understand to-froms, pull boxes, and then there's some other things that are kind of in the beta right now that are yet to come out in the first iteration of the software. But things like voltage drop calculations that are considered as we're doing design, material costs and labor units are this learning and this iteration. And I'll have a slide that kind of alludes to that. And then labor units as far as hours in the field. So we're going to look at those things. When we're looking at the inputs, again, we still require some type of inputs to come from the user. And Augmenta specifically requires a few different ones. The first one being an electrical model. The model will contain a lot of things. Mainly, it'll have some no-go zones or must route, may route zones. You could see in the picture here, I'm referring to a preferred routing zone in this green box that we've drawn in. There are also, don't go into an elevator shaft or stay away from this fire-rated wall. You do also need to place some of your equipment, so your terminal points, I'll call them in electrical design, whether it's a panel, a junction box, a light fixture, other things that you need to connect to. Those need placed throughout the model, so it has these targets and destinations to go to. And you'll see as we go through some of the results that you can kind of piecemeal or chunk out your design, so you're not trying to solve all things all the time. So keep going.
Adam,
yeah.
If you go back 2 slides, there's one thing that struck me, and this would be like me telling myself like 15 years ago when I first joined a major construction company, like just how complicated the model population process is for an electrical trade contractor, right? Like the conduit size is governed by NEC, right? Like you can only fill a certain percentage of that conduit.
Correct.
But the size of the conductors inside that conduit are many times driven by both the amperage and the voltage that's being passed through the conductors. But then you have the voltage drop because over the length of the wire, you lose voltage to the resistance of the conductor itself. So then the conductor has to get larger, right? And then the conduit, to maintain its fill capacity, has to get larger. And then you've got the added complication that you can only execute X number of bends, and I think code, generally speaking, is 360, but certain owners or engineers may have requirements for less than that, right? Like you can only put 390s or 645s into a single run before you need to intercept it with a pull box, and that pull box needs access permanently through the ceiling cavity, right? Like this is crazy complicated, right? Like it's really easy to just like evolve into a blob of protoplasm in your chair as you're trying to lay all this stuff out. Oh, by the way, sheet metal's going to come through, and like they're going to roll in like a 800-pound gorilla and just think they own the whole space.
That's right. That's
Right.
right. We
And
have a
it's
whole
like,
talk about the complication inside of electrical design. It is when you look at the numbers of pieces and parts compared to other MEP systems, we're basically double most of them as far as like SKUs that we'll use inside of it. And then most of the permit drawings that we see come through are typically lines, arcs, and circles. So we're starting from a zero-sum game in the coordination space. Yeah.
and you like, and the only way you know how everything's supposed to connect is hopefully the panel schedule, which sometimes doesn't get populated until like, the very last issued for construction set. Not the best practice, but that's sometimes what happens, right? And it's like, and then you join a coordination meeting, and some fresh out of school field engineers running the BIM coordination process and is trying to tell a detailer that's old enough to be his dad, why aren't you done yet? And it's like it takes everything they have just not to, rip the monitor right off the desk and throw it across the room.
That's right. Well, we're here to educate, right? That's what we do. We're here to educate and help them learn how we're looking at this.
Yeah. But this is equally big brain stuff. So I mean, we're not plotting vowels on an XY coordinate system, but it's still pretty darn complicated. So I just wanted to chime in on this because this slide talks a lot to the complications and challenges of a trade contractor that I think sometimes go underappreciated by the rest of the cadre of design and construction professionals that surround them.
Well, I appreciate that, John.
Keep going.
Yeah.
Vamonos.
Sometimes I'm too close to it, so those things seem normal to me. That's just normal life.
Yeah. Well, let's not talk about heat calcs, because if we're doing
Oh.
like massive underground duct banks, then I'm like, you just
and I have a question.
Go get a paper bag and just start hyperventilating into it.
Oh.
There you go.
Yeah,
I have a question,
no,
Adam,
please.
on you prior electrical model, ecosystems, file formats, right? Do you want to expand a bit on what's compatible with this?
Yeah. So currently, right now, Augmenta is working inside of the Revit platform for the generation of the solutions. So the Revit platform holds these items that we're talking about right now: the zones, the source and destination equipment. But then that gets processed into like a cloud mesh. Think of it that way, a proprietary cloud mesh that all of these iterations are getting run inside of. And then that gets retranslated back to the Revit platform. So it's published back to Revit. And then from there, again, you start looking at interoperability with IFC or other tools. And I'll go into some of the ways that it can coordinate with some of those other tools. Because it is built around the Revit platform, but it's built with an eye towards interoperability. So that's the third main input. We'll get there. So like the second main input, think of a wire schedule, and it's a basic to-from schedule that you look at like inside of an electrical contractor's world, right? An A to B. In the future, and again, this is on the roadmap and in beta testing currently. So during the pilot, I was able to test these features. It'll have a full-blown feeder schedule with sets, conductors, cable sizes, jackets, things that help with some of that specific conduit fill ratio or tray fill ratio type things that we look at. But today it's kind of leaning on, the electrical knowledge of whoever's inputting some of those things to make sure that we're not over evaluating those or over leveraging those systems. So it's like today, tomorrow. And then again, back to the geometry and coordination inputs. These are all the different types of things. It's basically anything you can put inside of the current Revit platform, whether it's a point cloud, a coordination model through other tools, linked files, IFC files, any of those things can be viewed inside of this proprietary mesh in the cloud and routed around. So it's seeing all of this and it's understanding the physical makeup of it and the XYZ of it. So all those different current model types can be worked inside of these routing preferences that it takes. All right. So 2 different ways we tried to leverage this. Initially, the directive was that branch systems aren't its strong suit, and branch being some of the smaller conduit from A to B, and then distribution being some of the larger conduit on a site that connects some of the larger voltage equipment. So the first case study we tried to apply it to, and again, it needed to have equally good tracking metrics on the job that we actually performed. So that's kind of what we've done. We looked at it from the electrical distribution side. And again, we gave it a bunch of inputs such as the feeder schedule, the wire schedule, equipment tags, all of these no-go zones. We had some elevator lobbies to avoid. And then there was an equivalent or a specification that said we had to have a certain amount of spares. So we had to incorporate that. And that was something that we were able to do with the tool. So again, the iterations of these, it turned out pretty good. I mean, this was kind of what we saw as our final iteration in a microscopic piece of gear. However, it wasn't the beginning, and I'll share some of the tools, right? So here's a side-by-side iteration on what we did. So on the red version here was kind of one of our first tries at it. And then we had to get more specific about the go zones and the equipment tags and the locations of the gear that we needed all of these conduits to go inside of. And you can see that here in the red version. It looks kind of like a waffle. I like to call that the waffle. And on the left side here, you can see we got a little bit better, not perfect. And what I've seen is that the tool gets a large amount of population done at a fairly high level, but 100% is not the goal here. Just like a clash-free model is kind of a misnomer. A perfectly run system is probably not what we're not what we're driving for. We're driving for like 90% or 95% quality population on a first try.
So Adam, I have a quick question on like process, or like I want to get a more tactile sense of how this works, right? So let's say you obtain the result on the right, you then run another iteration and it gets better, and maybe there's a bunch of other iterations to get you to the one on the left. Every time it retains, I'm assuming it improves upon the prior result, right? And it's
so we're training it. It's not training itself. Like that's not to the point where we're at. Obviously, the rules that we're giving it today will turn into its own self-governing rules. I was told that that's the roadmap clearly, but what we're doing is training ourselves how to tell it what we want and getting better at telling it what we're looking for. So like on the right-hand side, we said, here's 3 pieces of equipment that we need you to connect to. And then on the left-hand side, we said, okay, we need to break down the pieces of equipment to the specific location inside of that equipment. So gear section A, B, or C inside of each distribution panel here, right? So that's kind of what we did here.
Would another word for training, because like you hear everyone talk about like they're training their AI machines and like you get like visions of like grandiose stuff, but I mean, essentially all you're doing is redefining more accurately the constraints for it to solve against, right?
Absolutely. Yeah,
Okay.
that's exactly what we've done. And I've got a good story at the end to tell how I had to train myself better, how to figure out what to tell it to do.
Yep.
And that's a lot of what I've learned is that most of it will do anything you allow it to do, but to get it what you want, that's the hardest part is to train yourself to guide the iterations.
And I think as machine learning paradigms go, I think this is a supervised learning technically, right? Where you're actively improving the model. And I'm wondering at what point, and I mentioned this before when I was talking about generative processes, right? The fact that you have to basically run it and see how it needs to change. So it's essentially, I think, arguably a two-way training process where you're training yourself too, how to make the tool more useful and return better what you need.
Radu, talk to any general superintendent and they'll say it's all supervised learning.
Right.
Yeah, some things it was very good at. I mean, the spacing on the conduit, it hit perfect, no problem. And those are some of the inputs we had to give it is what's our spacing, what's our specification, what type of hangers do we want it to use, and so some of the things it nailed off the get go, but the other things, I mean, obviously we're not installing waffle conduit, and we fixed that pretty quickly.
That reminds me. I mean, Adam, let's say the model encounters a situation where a hanger is required for the routing and everything to work. Is the model able to figure that out and add a hanger to a certain situation?
Yeah, absolutely. And I think hopefully some of our variations on the further slides didn't get flattened with our presentation change, but they may have. But it will look at wall-based hangers versus overhead-based hangers. It'll look at the supports. It'll look at kind of what you've specified. So again, you can kind of upload your custom spec. So if a certain client is saying every time you're a foot away from a bend of a piece of conduit, you need to support that, you can build that into the training of the tool.
How about fire-rated walls, penetrations through it, recurrence for that? I mean, is that something that's also available? Yeah.
So if you look at, can it specify a UL system as it passes through a firewall? That today isn't what it can do. It can identify a penetration through a fire-rated wall, and then you would specify the UL system.
Okay.
Yeah, a good question though. Yeah. So let's just look in general what we kind of accomplished. I've kind of micro looked at a couple of solutions here, but essentially we placed manual placement of 68 pieces of equipment, and then we had to give it some information so it knew inside of this X, Y, and Z space that we call a model, where is this and what is it? That's essentially all we had to do. We placed it and then gave it a tag. But essentially we had it run almost 11,000 foot of conduit. It placed all those couplings. It placed all those hangers automatically and all the bends. And again, the final solution that we had there in green, I'd say it was about 90 to 95% of what we would have wanted. If you look at, how much of that 11,000 foot did I have to modify after it ran? How much of those couplings did I have to modify? How many hangers? How many bends? If you look at 5 to 10% of that, was pretty accurate of what second pass manipulation would be for that, which in my opinion was pretty good. I've seen some work that's less than that, but no, it was a pretty good opportunity. So we said, okay, that's what it's good at. What is it not good at? And what we were told it's not real good at yet is branch. And so I wanted to test that. And so we took a very much more focused approach, a very small project, but it did kind of replicate more of the type of work that we'd be using this in. That other project we looked at was a vertical healthcare opportunity. We just focused on the distribution. Clearly, there was a lot of branch conduit that we did not include. And again, trying to test it to that limit we peeled back and went to a smaller project. So again, just branch panel and junction boxes. And then again, here's some of the look of the solution. This is actually the mesh in the cloud. This is the way it looks. But we were looking at a lot less quantity of things. Tried to get it to populate, and I never was able to get it to do all of it. And we could talk through that a little bit, but essentially a much smaller scope with a much different approach with branch. So again, the problem is that we have these short floor-to-floor heights, right? All the tight coordination spaces that we're used to dealing with, and we wanted to see how it operated there versus more of an open floor or more of an open electrical room where it kind of has free reign to go wherever it wants. So essentially this is, and I think I've flattened these slides. So this is current most populated output we got from that second case study. And you could see it kind of went for some wall supports. It decided to run single branch conduits, which at that point is okay, but maybe I'm not supporting them with the trapeze. And then it had this strange approach towards the electrical room, and fun story on why it happened down there. But the evolution, and I started chunking this one out, and I had those slides here, but essentially I chunked out the upper portion of this model. As you see the vertical riser conduits, that portion I worked on itself, and that one conduit always seemed to like to go opposite of the rack for some reason. I could never get it to come back into the rack. It just kept going over there. And then the southern portion of that, or the bottom portion of that drawing.
Do you think there was a kind of a hidden constraint, Adam, there? Or like sometimes if this relied on Revit, sometimes it does unexpected things.
It's a ghost in the machine.
Yeah, there was a ghost in the machine.
Augmenta's developing a personality.
Yeah, that pipe, for whatever reason, kept going off. In the other iterations I had, there was actually two pipes that would go with it, which seemed to make more sense when there's two conduits that go out that way. And then eventually I got that one to reroute itself onto that main rack that you see all the way at the top. But that one, for whatever reason, I couldn't get it to come back, which is okay because it placed all those wall supports and I didn't want them anyway. So again, you get close to what you think you want from it. It can iterate it pretty quickly. And again, I had some chunked solutions. So I kind of worked on it piece by piece. Because again, it was a little bit more difficult to get the branch routing to work out. So again, the process, and this is a sneak peek. This is a kind of a small slide, but I didn't want to tease it too much. It's kind of a future endeavor for the program, but you can kind of see this plot map, and on the X axis you have the cost, and on the Y axis I believe it's the labor hours, and you can look at all those different solutions that it does when it runs the scenarios. All the different solutions there come back as far as, do you want to spend more on materials, or do you want to spend less on labor? How do you want to look at that? Is it a happy medium? Do you have a lot of available labor in a certain location that you're working, or do you have not available labor? And it'll run solutions based on those. And again, it's based on NECA units and labor units. And that's kind of the next evolution of what's going to come. So that's what that little slide represents up there. But how did it affect our current process? And I think that's really where we see, how this is going to change how we do things. What does that look like? Our layout team, they're typically taking some of those schematic designs from electrical engineers, and they're figuring out the physicality of the system, of the conduit system. So they're doing all that manually right now in different tools, whether it's like a PDF layout. You've seen colored pencils out on sites back in the day. So we've digitized a process similar to that. And we're also, as we're laying out those systems, we're saying, hey, avoid this fire-rated wall, avoid this elevator shaft, don't go
Avoid
through
the fire pump room, right?
Right, exactly. All those other scenarios that we say, maybe a modeler, someone who's very good at running Conduit and Revit, isn't real construction savvy. So we have this gap that we're bridging with that team. The modeling team, this data is now getting populated as the solution publishes back to Revit. It's fully populated with all the to-from data. In the future, it'll be all the conductor sizes, the ground sizes, the jacket sizes, et cetera, et cetera. So it helps kind of manage some of that rework inside of data management inside of Revit. And then our detailing team that kind of finalizes this conduit system, they're using all these tools and pieces and parts to kind of push in the final hanger locations, push in the conduits or C-fittings or LBs or LRs. And as we specify that with the solutions that we want, we can specify what pieces and parts to use so that we've now kind of moved the standardization up in the process.
Do you think, Adam, does this apply as well to like a design model versus a construction model, given the difference of the priorities of the teams because I was thinking, okay, in a design model, which is where I live most of my time, all of it, coordination is huge, right? And coordination during design, which basically, things move. You have to follow the pecking order of like discipline you are, right? You have to move or maybe not move, depending on where you are on that chart. And so it's a whole sort of like fluid process, complicated, a lot of moving parts, which I'm not so familiar with the construction model. Building and maintenance may not be as much applicable as it is for a design model.
Yeah, I think that an electrical design company would benefit from having a tool like this, so that the distribution project was a design assist job where we got engaged as an electrical contractor. We started rearranging potential locations for all of the electrical equipment inside of it was like a 50,000 square foot floor plate. So we took some scenarios and priced some scenarios of moving that equipment around. And that was all move it, check the length of the runs, rebid it, rebudget it, send it back out, move it, run the length of the runs, rebudget it, send it back out, and start to look at these scenarios. With a tool like this, we just move everything where we would want, rerun scenarios, look at that magic graph, grab the one we want. And we start being able to iterate real quickly. And I'll get into more of how we did that. So I hope that kind of answered it out. And I won't forget, I have a slide to talk specifically about that. But the workflow timeframes, and I'll just think about what it did. And I'm pretty conservative here when I put things like this on paper. But we're seeing a lot of time savings in doing some of this manual layout process, because again, we're not duplicating the work that's getting done is immediately valuable downstream. And whether it's downstream to an AI generated or generative AI model, or if it's someone populating a model, you can see how digitizing a layout process inside of the same modeling software that our modeling team is using would be beneficial. And I tried to apply a team member cost based on, and not look specifically at hours, but we'll get into that. Our modeling team, again, first pass population, if I can say 70% of my model population time is going to go away, that's a pretty huge savings for a team that starts with, again, mostly lines, arcs, and circles and some equipment. So we're adding a lot of people inside of our team based on that capacity add. And then the detailing team, maybe a little bit less, but we're just kind of fixing a couple things inside of our process and streamlining that. So apples to apples, I did put hours together with this and looked at how we did traditionally, how we did using generative design, and what we saved. And the traditional layout, that took a lot of time for us to specifically route because of all the scenarios of pump rooms. There was a pump room on the mechanical floor up there. There was electrical, there was our electrical room. There was an elevator room. And then there was a kind of an east-west chase that we had to operate inside of. And that had to be specifically schematically drawn by our team. And that kind of went away when we just had these go, no-go zones and could just toss some pieces and parts and then upload a sheet of information.
So
Go ahead.
Adam, one thing to look at with that 319 hours is that generally speaking, on most projects that don't have a robust DFMA approach, layout, modeling and coordination and detailing, all of those activities essentially sit on the critical path of the project.
I would
right?
agree. Yeah.
And so 319 hours of non-critical work has $1 value to it from a project value perspective, right? Like risk of liquidated damages and everything else. And 319 hours of LD critical path time is worth a whole lot more, right?
Yeah.
So
I would agree.
I think there's also the lexicon of these are hours and hours are humans and humans get paid time or they get paid time and a half, right? If it's critical path, then you need to push OT. But then there's the bigger picture of, okay, if you're able to accelerate your coordination schedule by that number of hours, which is essentially 2 months of one person, right? But you're not putting one person on it. Nonetheless, like if you can knock 2 weeks out of the coordination cycle, that's incredible.
Yeah. I agree. I think this helps electrical align a little bit closer with some of the tools and pre-coordination work that gets done with the piping, plumbing, fire protection, because some of that work gets done in the design coordination. I am seeing some electrical population, but this gets us to a point where we're kind of starting to catch up, thankfully. We'll look at the branch. The branch, we didn't have quite the same savings if you just take it piece by piece. Again, the layout time, we're using a tool to kind of design our conduit runs for us, right? That's really the true savings, where we're not grouping circuits and things like that. It's taking care of that for us. Again, it needs checked, but it saves a lot of that initial layout time and then the initial population of the conduit. It didn't save as much on the branch routing because, again, there's some more rework there, but I'll take some savings. If you look at the bottom line of a VDC services company and you say you can start leveraging a 5 to 6% savings, I think they would take that. So I'm realizing a little bit better than that. Just to kind of say, hey, how'd you catch this data? I've kind of tracked, and it's changing every week, but I think we're about 192,000 VDC hours inside of our group. And we're tracking it down to like the task level of what we've been doing. So that's kind of just a background of, hey, how do you know that you actually did this? We pulled all these hours and put them back together. Key considerations, again, the connecting to the value to the estimating team, I kind of talked to that. But I think as we start seeing that beta come to fruition with the tool, we're going to start being able to really look at these design assist projects and adding value, not just a VDC team, draw this up and give me a length out of the model. It's going to be more like, hey, VDC team, model this up and show me the cheapest scenario that you can run. And that can start being a discussion. The capacity clearly, and we've done a lot of process mapping to understand our current state process, so that when we're looking at tools like this, we kind of see where the steps in our process are going to be affected. Anytime you're implementing a new tool, I'd recommend that if you're not already doing that. And then the standardized inputs are really going to start helping us standardize the outputs. So if I tell it only use hangers in 6-inch increments, things like that, we can start eliminating some of the custom stuff that comes through either our fab shop or back out to the field. And then again, I think, John, you mentioned it. It allows us to compete with today's project schedules, and it's not float on the schedule that we're saving; it's critical path. And I promised I would talk about this because something looked very strange if you're looking at conduit routing on some of those solutions I showed for the branch routing. This is another A and B solution for the branch routing, and you can see it did some strange things over by the panel, and it went underground, and I couldn't figure it out. I spent many iterations solving this problem, and eventually I solved it. But what I realized is that in every electrical model I've built for the last 10 years, I've had a clearance in the front of the panel. I've had a clearance on top of the panel to represent code clearances. And when I published the solution to go figure out how to run the conduit, it kept going underneath the panel and I couldn't figure it out. But I'm sure you know that I didn't turn the clearance off. And because I didn't turn the clearance off, it saw it as an obstruction and tried to find a way around it. So this is something I had to learn, is not something I ever think about removing a clearance, but because it sees it that way, it went all over the place. So I thought it was a problem with the tool. I had the team come in and try to help me. They couldn't figure it out. Eventually we did figure out that it was just the clearance. So that's another thing that I'll give you is, have patience with yourself, have patience with the tool. There's some counterintuitive things that it does, and there's probably a reason. Or it's a ghost in the machine.
I mean, there's a reason we have clearances for clash purposes, right? I mean, they have to be available there for the unit to serviceable and whatever. But do you have? I mean, not your field or trade, but MEP. I mean, MP component to this. I mean, is that under development?
Yeah, that is on the roadmap. Again, I think there's an opportunity with the lines, arcs, and circles that represent a lot of conduit systems. And there's, if you look at where the opportunity is in the space right now, it's probably electrical for a tool like this. So I think that's why they went that way. And we always get left out. I mean, that's how I feel. But no, they are currently looking at engaging some folks as we did electrically in the mechanical and the sheet metal space. And again, I just want to put it up quick. There's some folks here from Augmenta that have been great to work with, and if you have any questions, you can reach out to me or you can reach out to them.
Adam, a question for you. Were there so you've gone through some surprising results, but were there other things that you'd have never figured that come your way from this before you embarked on the project?
Yeah, when I was starting to look at the ROI of it, I never really understood the benefit to our entire process. I always thought of it as a model population tool, right? It's going to save me time drawing conduit and our team drawing conduit. I never thought about how it would align our process in a digital way so that we are creating, we have a lot of waste if you look at traditionally in our process. And I think I knew that, but I never tried to quantify what that was. I always thought it was always, there's a little bit of waste there. But moving our team as it goes through our layout, our modeling, and our detailing process, trying to align those in a process that adds value along the steps and eliminates that waste, I didn't realize how much it was there. So I think that for me was one of the biggest surprises. The other thing was how some of the way I look at custom conduit design, and how this looks at a programmatic approach, saying, okay, I want the hanger here, I want the edge here, I want the first conduit to be placed here, started making me think, is there a happy medium between custom conduit design and full generative design that I can have some type of repeatable design? So it had me start thinking about that as well.
Very cool. And I think you've talked about quantity takeoffs. One of the things that's in mind is whether how did you dial in, and you touched on it, but the optimization of the result, was it mostly driven by cost? Was it how can you maybe sort of a la carte create a set of results that are maybe there's a hierarchy to them, and maybe cost is on top, but can you like kind of like dial it in that to that granularity?
Yeah, the solution I tried a bunch of the different options, from the cheapest to the most expensive to the least amount of labor to the lowest amount of labor. And what I was trying to replicate was what we actually did. So I played around with it, but I was trying to get it as close to what we actually ended up with for design. Whether that was the right approach or not, I'm not sure. I never quite got exactly there.
Kind of like reverse engineer it in that sense.
Right.
Yeah.
Right. Exactly. I tried to reverse engineer. With the distribution, we got very close. I'll say very close. With the branch, it always seemed to do a little bit of what it wanted to. And then quantification,
How is that different from branch most of the time?
I mean, it's standard stuff. I mean, 60% of our labor. I don't know that I quantified, other than like the footages were always a little bit more. The supports, surprisingly, with the material cost, seemed to go more towards the supports and less towards the actual physical pipe. That's one thing I found when kind of looking at those back to back.
And I think a question. I'm sorry, go ahead, John.
I was just gonna say, like, one knock-on benefit when we're talking about material and labor costs is if you catch your detailing and layout process early enough, then you're installing your embeds for supports in like your composite metal deck before there's concrete, which, you know, with the blue banger hangers or whatever Hilti offers, that's the same thing, right? It takes 30 seconds instead of, you know, some poor craft worker up on a ladder or a piece of scissor lift drilling overhead with an SDS, you know, max, and just feeling nothing but vibrations nonstop, where it takes 15 minutes to install a single hanger. And then they
Yeah.
get something in their eye and it's like a huge thing, right?
Right. Yeah.
So like there's intangibles as well to this entire thing where it's like, okay, a few extra hangers or whatever is completely it's gonna more than come out in the wash
That's
when
right.
you get work installed in the right sequence.
I think a business case of cost savings is tremendously helpful for like any new tool, any sort of new environment runs against, in my experience, lack of trust and sense of like losing control over your process, right? Which comes from like, I mean, especially in I would say engineering world is very strong in my experience, as I've been in MEP for many years. And so that's always like having a tool do it, as opposed to me as the engineer, or maybe me and my designers kind of thing. It's always a tough proposition. But I think that what can solve that out, and it sounds from your experience, Adam, that that's actually what happened in your case, is that there's a business case to be made of cost.
Yeah, I mean, we have to give some type of ROI for why we did it. Part of it was to learn the tool, help shape the way the tool works, give input to an industry changing tool, and part of it was selfishly to try to build my own ROI for why I thought it would be useful for our company to pay some money to use it. So, well,
I mean, you got there just on pure hours, let alone all the intangible stuff.
yeah, I tried to speak the project manager language, dollars and hours.
Yeah, that's providing success usually.
Yeah,
I think a good PM sees the intangible. The accountants just see the black and white, right?
that's right.
So you nailed the project accountants too. They got nowhere to go.
And I think what a time.
Yeah, we are. We're not out of fun.
No.
We're out of time.
I think hopefully I think it's a topic that this is not going to be the last installment on the topic for sure. I'm positive. So We may wrap it up today, but I'm sure there's a lot of new tools to look at. Hopefully, maybe there's an MP tool. There's a landscape tool. I don't know. Like we're looking at the plain future here, and hopefully we framed it in that way with the historical, quasi-historical overview at the beginning, and then the future is upon us.
Right.
Yeah,
You know,
it'll be
maybe
exciting.
maybe the next thing we do is we look at the tools like QPix and Doxel, which, you know, they compare back to the model to track progress and project completion, right? Because
Yeah.
if you're going to go through and you're going to let AI or machine learning go through and build you a very comprehensive model, and then you can go out and have near automatic verification of percent complete, like, it's fabulous. We've completely closed the loop on the ability to, you know, have hyper accurate pay applications. You had what, like 11,000 linear feet of conduit, right?
Yep.
It was like 10,998 feet, right? But
That's
if
right.
if a tool could automatically go and measure the completion back to that, and you guys complete 10% more that month, then you get paid 10% more. Obviously, there's like retainage and everything else, but
That's right.
you know, it's completely incentivizing high performing trades. That's exciting.
Fantastic.
Well,
All right.
I appreciate that.
Radu and Adam, how are we wrapping this thing up? Because I'm watching. We're into extra time.
Yeah. I think you said it well, John. I think the conversation continues, and happy to share anything else that anyone reach out to myself and Radu. Just a great job setting the stage for how we're looking at generative design and where it's come from.
And probably you can also say that there's a bunch of events brewing from BIMForum on these topics, the things that John mentioned, and we can't say anything more specific than that, but
right.
We're heading that way. So stay tuned.
Thanks, everyone, and this will be up on YouTube shortly. Cheers.
Thank you.
Thank you.